Okay, now we're going to get on to a new topic, Lesson 4, Averages and Probability. You'll see there's some pictures of an old-time baseball player and some playing cards and some dice. So these are some of the exciting topics that'll be part of the motivation for these lessons. Probability has a lot of stuff that's used in gambling, and averages take place a lot in baseball. So we're going to talk about that a little. So in case you're wondering about the real-world applicability of this stuff, there's a whole lot of it. Not just in terms of the things I specify, but averages are used constantly. You're going to see them in grades, in your scholastic pursuits. You're going to see probabilities used constantly in computers. Anything but average. I have a picture there of Babe Ruth. He was one of the Yankees and one of the most famous baseball players of all time. So what's an average mean? We're going to talk about mean, median, and mode. Babe Ruth, born 1895, died 1948, has among the highest lifetime batting averages of the post-dead ball era at 342. This means he hit the ball an average of more than 1 out of every 3 times. The mean, or the average, it's the same thing, is equal to the total of the values of a data set divided by the number of elements in the data set. So let's take a very simple example. The batting average with 3 at-bats with 1 hit, 1 strikeout, and 1 pop flyout would be 1 for the hit, 0 for the strikeout, 0 for the flyout. So 0, 0, 1, that's our data set. And we'd go, okay, there's 3 elements in that, so we add up 0 plus 1 is 1, and we divide that by the total number of elements in the set, which is 3. 1 divided by 3 is 0.33. So in those 3 at-bats, the average would be 0.333. So let's take a more complicated example. We're going to do an average of averages. If someone hit 0.350, 0.200, 0.250 over 3 seasons, the average would be 0.350 plus 0.200 plus 0.250, and we divide that by 3 because the total number of seasons would be 3. We come up with an average of 0.267. An average indicates performance or another variable over time, or another variable. So rather than look at how Babe Ruth did in 1 at-bat or even 1 season of at-bats, we get an idea of how often he hit the ball over his entire career. He hit the ball a little more than approximately 1 out of every 3 times, which is pretty good in the major leagues. Actually, it's excellent. Moneyball, a popular film that I'd recommend you see with Brad Pitt, is about sabermetrics, which Oakland A's staff member Billy Beane was one of the pioneers. That character is played by Brad Pitt in the movie. He also wrote a book. And they came up with something called on-base percentage versus the batting average. And the on-base percentage looked at statistics a little differently. And instead of checking how many hits a player got, they just checked how many times that player got on base. So walks mattered too. So if you're ever wondering, well, what's the statistics used for? This all seems like only if you're doing math or only if you're doing this or that. Well, it turns out you can use it in baseball. The Oakland A's became one of the most successful teams despite a very small budget compared to large teams because of the fact they used statistics. They used things like mean, median, and mode in something called sabermetrics, a specific kind of baseball statistics. The problem with averages. Say we want to figure the income of a group of people to get an idea what the income level in the area is from 7 people. We would naturally not use a sample size this small. We'd use one with thousands, but the same thing would happen. So I'm just going to show it. So if those 7 people were making $50,000, $40,000, $30,000, $25,000, $40,000, $15,000, and $35,000, we'd add them up and divide by 7. So 235,000 divided by 7, 33,751. it doesn't look that out there. That seems about in the ballpark. Now let's look at the median or middle number. If it's an even number or set that we're dealing with, you divide the middle two. So we have 15,000. You put them in order first. 15,000, 25,000, 30,000, 35,000, 40,000, 40,000, 50,000. 35,000 is the fourth number, and it's right in the middle. Okay, so that seems like, okay, that's a decent guess, right? That's in the ballpark. Let's look at the mode, or the most common number, which is $40,000. That appears twice. It's the only number to appear more than once. So say we figure the income of a group of people, and we want to get the idea of what an income level is in the area from a group of 8 people. Okay, I added one person. It's the same numbers with one person added who makes $100 million. The mean now, since we took all of those and divided them by 8, is $12,529,375. Do you see something wrong there? You should. It seems a little out of sorts, right? We had one outlier that throws everything off. Say a Mr. Burns from The Simpsons, or Bill Gates, who's one of the richest men in the world, or someone else like that. They could easily throw off the average for an entire community. There could be thousands of people, and if you had one person worth $1 billion or $100 billion, that could throw off the average for everybody. Now, instead, let's order them and look at the median or middle number. And remember, if it's even number of the set's an even number, we average the middle too. So we put those numbers in order: 15,000, 25,000, 30,000, 35,000, 40,000, 40,000, 50,000, 100 million. And now we see the middle number. There's, okay, let's go over. There's 8. So 1, 2, 3, 4, 5. We have to go for the middle of those two. So we average 4 and 5. We get 35,000 plus 40,000 divided by 2, and we get 37,500. And the mode, or the most common number, is 40,000. Both of those are a lot closer to representing the community than the mean in that instance, the sample set. Okay? So sometimes it'll make a lot more sense to use the median than the mean. The median gets rid of outliers in terms of figuring out the number that matters, that's representative of the sample set or community. An important thing with averages, the best way to practice this is by doing problem sets. This isn't a difficult concept. You'll understand it better the more problem sets you do. And that's it for this lesson. I'll see you next time.